Hello, 8th grade. Happy Easter. He is risen. He is risen indeed. I hope that you have had a wonderful Easter weekend and you were truly able to enjoy it knowing that you had Monday off. I know that I am so thankful for Easter Monday so I can truly enjoy Easter Sunday with my family. I wanted to share with you what this week's expectations are and give you a little lesson since I missed our live session on Monday or today. So here is your schedule, your post for the week. Tomorrow you are going to watch this video, hopefully, and learn a little bit about weather fronts and air masses and jet streams, and you're going to do that also through completing the Edpuzzle video that was assigned to you. If you look at your assignments, you will see that down here that it has been posted that under your meteorology understanding weather. Now, it might be confusing because it says that it's due on Thursday, but please notice that the Edpuzzle is due Tuesday. So I'm going to try and put a calendar reminder in there, but I do want you to do this current events Edpuzzle on Tuesday. It will take 5 to 7 minutes of your life. Please start it. Also, I'm asking you to watch my video and then open up the weather forecasting simulation on Discovery Education. This is that simulation I'm referring to. It's kind of teaching you how meteorologists work and how they begin to study and predict our weather forecasting. So when you come in here, I do want you to read the Start Here section. It really does help if you read this Start Here because it turns out it gives you information that you need to know. Like, what in the world is a front? Or what are air masses? And I'm going to give you a little heads up that air masses are huge bodies of air that are of similar temperatures and humidities, okay? And we have 4 major air masses on and around the United States. And you're going to need to know what those 4 major air masses are when this simulation is done. Those 4 major air masses kind of help decide our weather. And if one of those air masses collides with another air mass, we get what is called a front. And a weather front is what determines what weather we have in our area. You've probably heard of high and low pressure systems and hot and cold weather fronts and what kind of weather they'll bring. And if we have a hot air mass and a cold air mass collide, what will happen? Well, that's what you're exploring through the simulation. So read that Start Here. After you've read that, I do want you to read the background information as well. It gives you some about what weather and climate is, but why do we have weather? What is humidity, air temperature, pressure, and wind? What are all those words? What do they mean? And so those are words that you are expected to understand. So please make sure you read this background information to kind of understand that. And know that our air masses are our large body of air that's uniform temperature, and that they move around. They are not stationary, but you can find out what the 4 major air mass types are within this reading as well. And we also know that air masses change the weather over the regions as they move. When air masses meet, we get something called a front. A front is a boundary of air masses. It's classified as either warm, cold, stationary, or occluded. So this is where most of our bad weather experiences come in, is where these air masses collide and form a front. So you're going to learn about all 4 fronts, the characteristics they have, and what kind of air masses come from it. Once you've done that, I will give you a clue. If you click on the eyes, or if you hover over the eye by the different types of air mass fronts that we have, it gives you information like where in the world you might find a continental polar front. I'll give you a clue. If it says continental, it's probably over land. And if it says polar, it's probably cold. But they also tell you about their temperatures, how much humidity they have, and things like that. Now, the other clue is if it says maritime, it means it's probably over water. And if it says tropical, it means it's probably warm. So these are some context clues you might want to take. But here's what you're going to do, though. If you put a continental polar air mass in air mass 1 and a continental tropical air mass here, it's going to show you what will happen. And so our continental polar is going to be our cold air front. It's colder, it's denser, so therefore it's going to push, and it moves faster. So it pushes underneath that warmer mass. And so we get a cold front. Notice the blue triangles pointing in the direction that the front is moving as it pushes under that warmer air mass. When that happens, it does collide, and we get long periods of rain that happen there. All of this is told up in this information. So don't worry, you don't need Miss Mick telling you. The computer will tell you. But you do have to read. There is another part of the simulation, and this took me a long time to figure out, sadly, I have to admit that this forecasting map is actually quite separate from there, because I kept thinking, like, well, why is it cold here and warm up here? So these are our different types of fronts. And so, for example, if they're showing on here, hey, there's a warm front moving in, now they want you to be the weather forecaster and predict, okay, if there's a warm front moving through and it's going this direction, what kind of weather might I have? I haven't done any background research yet, so I have no idea. So I'm going to say, ooh, warm sounds nice. So it's probably going to be sunny over here. And then if it moved through here, it's probably now rainy over here. And it's going to be warmer over here because that's the direction of the front. So therefore, it's colder over here. Ta-da, that's my prediction because I've done no background research, so I don't really know. If I check my forecast, it'll show me what it should look like. And actually, with a warm weather front, we tend to get clouds. They move really slow, and as they move through, they're moving into a colder area, so that's why it's still colder over here. And so when they come into that colder area, the cold fronts tend to have rain, and it gets cloudy as those slow moving warm weather fronts come in. After that front has passed through, however, we get sunshine. So there's sunshine over here. So this is where you can do some predictable forecasting. Now, once you play around with it a little bit, there are questions. I don't actually have you answering these questions. You can look at them just to see if you're gaining understanding. But what I do have you doing, if I can find it, is we have this little presentation you're going to be filling out about weather forecasting. I put the link in twice to the simulation here and there just so you don't lose it, okay? And it has you reading the directions on this page. Okay, I obviously just took pictures of Discovery Ed's papers and put them in here. But then I've inserted text boxes to you. So if you click in any of these, you can just type away, ta-da, and your text should show up. Okay, so try not to move those text boxes all over. If you do, don't stress, just copy and paste a new text box in. It's no big deal. But they want you to tell me what type of front is being pictured here. They want you on the simulation to try and form a warm weather front that's moving westward. Okay, tell me, what is this air mass? And what is this air mass? Describe the air mass movement. Is it fast? Is it slow? Is it high humidity? Is it low humidity? And then tell me what type of weather is formed. So use this picture and answer that question. On this page, they're wanting you to tell me more about the 4 main types of air masses we have on the United States. And again, if you click on the eye that I showed you, then you'll find the answers for this table. Okay, but it does tell you, describe one front it forms with another air mass. This tells you have to play around with the simulation. So if I mix continental polar with continental tropic, you can say makes thunderstorms when mixed with continental tropical. Don't believe me. That may or may not be true. So please do the simulation to see what happens when they mix. There are just some other questions over here that relate to it. Which of the 4 North American air masses shown in the simulations form over oceans? I'll give you a clue. There's 2 of them. What do these air masses tend to have in common? Again, if you look at that background information, it'll tell you. If water absorbs heat in the summer and gives off heat in the winter, what can you assume about the weather in places near the ocean? So think about that. Places near the ocean, what's the weather usually going to be like if it's always absorbing that heat in the summertime and giving off heat in the winter? Now, we know that heat affects land and water differently. That's super noticeable when you live along the coast. So on a sunny day, we get our air over land heating up faster than air over water. So how could you notice this if you were standing on the beach? We've talked about this concept time and time again. I certainly hope that either the video you watched in Edpuzzle or our live session last week helps you know what to say here. Oceans cause some of Earth's most violent weather, including hurricanes and tornadoes. Learn about these 2 types of weather in the chart below. Don't worry, the chart is on the next page. Which is larger, a hurricane or a tornado, and which has stronger winds? So if you come here, it's going to give you those answers by reading a little bit more about hurricanes and tornadoes. What in the world is the role of an ocean in a hurricane and tornado? Thinking about the fact that they told us it's always absorbing heat and then giving off heat. In the hurricane, the area in the center is called the eye. What do you think it's like when you're in the eye? And that's that big open space in the center of a hurricane. And then do you think hurricanes could form over the Arctic Ocean? Remembering that the Arctic Ocean is far away from the equator, therefore getting more indirect sunlight. Why or why not? So I want you to think about those things as you work through this weather simulation, okay? So your Tuesday, Thursday work this week is doing the Edpuzzle on Tuesday. And you can go right ahead and do the simulation on Tuesday as well and be done with your STEM requirements for this week. And once you turn in this assignment, ta-da, then you are in a good spot. Now, that being said, though, I want to point out that there was another assignment that went live today, and it is your climate/water cycle alternative assessment, okay? And it just is that you are going to be assessed on this unit through a project, presentation, visual using whatever media you want to tell me about the major concepts of this unit. And it is focused upon the water cycle because the water cycle drives everything in relation to weather and climate. It also drives everything in relation to life, and it's what makes our planet unique and full of life. So therefore, since it's so important, that is the focus of our assessment. That being said, I do not want an elementary 5th grade level presentation on the water cycle. I am looking for a deeper level. So please notice, in your model of your water cycle, you are talking about the basics: evaporation, condensation, precipitation, surface runoff, surface water storage, groundwater storage, otherwise known as aquifers, collection, convection, and infiltration, as well as gravity in relation to the water cycle. Please note, if you saw asterisks next to a word, it is bonus opportunities. You're not required to go over those words, but you can. Now, other things though, and I would say that these things are probably most important, is you need to tell me and provide a visual as how the water cycle affects climates that are coastal versus inland versus mountain and valley, okay? Because all of the climates are different in these locations. Mountains have different climates because of the way the water cycle works versus valleys versus inland states versus coastal states. So tell me why that is. And then provide insight and discuss why the water cycle is important to understand and monitor, and how pollution and growing populations affect the water cycle. These are some things we talked about last week, but you are welcome. Actually, when you do further research, you might find out more. And I've given you some different research resources down here. You are not limited to these 4 resources by any means. These are just some great places to start. Your rubric, of course, is attached below as always, and it tells you how I'm going to grade the different parts. It's due next Thursday, so you can start your research and start building your presentation anytime between now and then. If you have any questions or if this stresses you out, please talk to me. I want to be here to support you, but I can't support you if you don't reach out to me. Anyhow, again, I hope you had the most blessed Easter. I miss you tremendously. I wish we were doing this at school together, but I know that I can count on you to be responsible and do an amazing job on these projects anyhow. Talk to you soon. Bye.